My name is Leah Wells. I'm with the Mineral Development Division of the Department of Energy and Mines. We're about to present some great projects that are affecting regions from central right on over through the west coast. The first one that we have coming up is the Great Atlantic Salt Project. The Vice President of Engineering and Contracts, Bob Booth, will be presenting here now. And it's going to be a fantastic project that's going to have some great impacts on the St. George's area. So everyone, please welcome to the stage, Mr. Bob Booth.
Okay, I'll screw it up. That's not a problem.
Not a problem.
Good morning, everyone. Can you all hear me without the microphone? Yeah. There we go. Good stuff. So, very glad to be here. I usually, for the technical talks, I'm opening the technical talks this year. Usually it's, I open for Springsteen and Coachella in California. But thank you, Gander, for a nice storm. And we're here to have some fun. Speaking of which, I did do some checks on the local bars. If we do get stuck, the tequila inventories are very high at 7 of the 9 bars. I'll let you figure out which ones are which. Okay, so let's talk about what Atlas Salt's up to here. Oh. Hello? Test? Ooh. Okay, that's a little loud. All right, guys and gals. So we're talking about the salt mine we're building out in St. George's. And it's a very green project. It's going to be an all-electric mine. Very low greenhouse gases, employing 250 people. We're producing road salt for de-icing, and I think that'll come in handy for what we've gone through this last winter, all through Canada and in the States. Mining-wise, it's going to be a room and pillar underground mining method. The deposit's very flat-lying. It's a 25-year proven reserve, with 50 years of extra mining to come after that. Literally, that's the nature of salt deposits in terms of they just keep on going like the ever-ready bunny. So here's the layout, what we're proposing. Access road into the site. We're very close to St. George's. Very small stockpiles. The only waste stockpile we have is for the organics and what we have to do to drive the twin declines underground. You can see up to the center left the twin declines. One decline is going to have a conveyor system running down 1.5 kilometers underground to the infrastructure area for sizing. And the other one is for access to the mine. So what's happened in the last year? I was here last year talking about this. We had just finished the updated feasibility study. And we had finished the geotechnical work. Terrain and Gemtech and Logan Drilling helped us with that. We've secured relationships with Continental Conveyors. This is really a logistics project per se because of the length and the length and distances of the conveyance systems. The underground feasibility, SLR updated it. It was just about done about the time I was talking here last year, but I've got some updates. Sandvik has come along and bumped their financing for equipment from 73 million to 132 million. So we have that relationship well in hand. And that's going to take care of everything from ground support to automation, which is going to be a big part of our project. The other components, land acquisition, although the mine site itself is on 38 hectares, we bought up a lot of the property all the way around and obviously all the surface leases and mining leases. And we've negotiated with Newfoundland Power. We have that all set up when we start our execution. So what changed? So there was a feasibility done in 2023 just before I arrived at Atlas Salt. So what changed? So we went from mining 2.5 million tons a year to 4 million tons a year. So that shortened the mine life by about 9 years of the proven reserves. It made a huge difference in terms of the profitability of the mine. the design of the declines had to change. So we did that geotechnical drilling I was talking about with Gemtech and Terrain, and we found some surprising results that we needed to de-risk, and that's what we had the time to do it, and I'm going to talk a little bit about what that looks like. We've had to upgrade the ship loaders and its abilities to take on larger Panamax ships, 40 to 50,000 ton ships, versus what's coming into Turf Point right now, which is much smaller in size. And just after this session this morning, talking about working with the community, there's a steering team we work with in the town, and we looked at all these trestles that were in the original design, and we've eliminated those trestles and put in different setups to deal with the ugliness of mining at times, if you will. So the conveyors are going to be closer to the ground, continue underground as we get closer to the coast. The railroad bed that runs right across the province, the historical railroad bed, we have an overpass for that, so the sledding and the ATVing will continue as it is right now. And there's a very scenic walking path down towards the marina, which is very important to the community. So we've engineered some things to allow for that to be part of the design. And that goes back to some of the conversations they had earlier today, is about getting the community involved much sooner, and you solve problems before they occur. Okay, so you look at our production rate, I talked about that for 24 years. It's going to be about 51 months of execution on the project side before we're producing, which puts us in closer to the end of 2030 because we are doing some work right now. And a lot of that's due to the work we've done to optimize the feasibility study. So let's talk a little bit about the geotechnical. So what you have here, Logan Drilling did the drilling. You can see these light yellow lines. Those are the 2 declines that go down to the salt body. So we drilled holes on surface. The purple or blue is where we drilled our geotechnical holes on surface to get down to that area. And so there's about 20 holes, lots of testing for on the hydrology side. And the key findings were the strength of the ground to get down to the salt body is much softer than we ever anticipated in the original feasibility. So example I'll give you, the granodiorites where we mine gold mines in Newfoundland, that's about 175 MPa ground. Shales, a good mature shale or sandstone can be around the 65 to 90 MPa. The original feasibility said this was going to be, what does it say here? It was originally going to be 5 to 53 MPa, very soft ground, but with the geotechnical drilling we did on site last year, it's between 1 and 17 MPa. So the idea that I even talked about to the group last year was, okay, we're going to bring in some road headers because the ground's too soft to drill and blast, and we're going to bring in a road header, right? The road headers in this type of ground would just sink into the mud, right? So that method isn't exactly going to work for us if we're digging with banjo shovels to unstick tracks. So we looked at a different design and a different methodology, which is the hydrostatic liner, which I'm going to talk to. The other thing we found when we did this geotechnical drilling was the presence of faults. So there's some major fault lines going through it, and it's how you access in front of the, as you go through these faults, it's very important that you minimize exposure to the strike of the fault. Groundwater inflows were modeled, and when we put in this hydrostatic shell that I'm going to talk about, it ended up reducing inflows by 95%. So water is very bad for salt. What we've done is taken care of it with the hydrostatic shell around the access to the openings to mitigate the amount of water that can make it down there. Even if we do run into some water, we're in a situation where we have an NHL pumping system. And I'm not talking about Toronto Maple Leafs NHL, I'm talking about Stanley Cup champion NHL. Who's going to win this year, I don't know. So this goes back to the faults here, right? This was the original plan. I don't know what I'm doing here. Go back. The original plan had us just doing 2 straight declines. You can see we have to put a dog leg in because of the location of these faults. So no problem. We get the data, we understand what the problem is, and we mitigate the risk. So this is where we talk about the hydrostatic shell. So what you have here is, this is the same methodology that was used at Carrickfergus mine, in Carrickfergus in Ireland. Kilroot mine is a salt mine in just north of Belfast, which is considered to be our sister mine, typically because of the ground conditions that they went through and the type of mining plan they had in place. So a lot of what we've done were modeled on the lessons learned from Kilroot mine. And very early in the process, they switched over to a hydrostatic liner, hydrostatic shell. And what's involved here is it's a full circular. So just picture a concrete pipe, 8.5 meters or 9-meter diameter going right down. And we're going to have to hang the conveyor system off the back here, which is an engineering feat in itself. So having the right design in place to deal with this, and then you fill in the bottom. So this is much more expensive, and a big part of where the CapEx went up when we updated the feasibility study. But money well spent in the extra engineering we did. We brought in Shafts and Tunnels, who did the work at the Kilroot mine in Ireland. And when we were up in Ireland, we had lessons learned with the management team in Ireland. And after several Guinness, we took back all the information we needed to be able to apply this to our project in a sober manner. Okay, so you can see here the excavation method. There's no jumbos, there's no big road headers, continuous miners. It's essentially a John Deere backhoe that picks away at a small portion of the face. And why do you think that would be? Collapse with water, right? So you only want to open up very small openings. I had this situation where I put in a raised borehole on this other project. It was 1,000 feet. And what we had to do was the borehole, the pilot hole for the raised bore, was making about 8 gallons a minute. So we said 8 gallons a minute, not a big deal. Well, you put the reamer on and go 18-foot diameter, it was making 2,500 gallons a minute. So what we had to do was stop and pressure grout and create a grout curtain all the way around this raise. So very similarly, what we don't want to do, this keeps on jumping, I guess I'm moving my hand here. What we don't want to do is open up too much ground at once. So you put in your preliminary liner, then you go to your secondary and primary liners after that. And they will vary between 300 and 600 mil. And that just shows you a sequence of how you pick away at the face and the advanced work you do for spiling to protect the ground ahead of you. So this is what it looks like. This is a shotcrete machine working at the face. You can see you've got the backhoe back here to the right. And you just pick away at this, and it's very specialty shotcreting. This isn't your average shotcreting. You bring in a crew in a hard rock mine that might not have the right amount of silica fume, and it's not going to make a big difference. This has to be very much on spec for anything we do, and this is the end look of the decline. This is the Kilroot mine decline, and that's essentially what our declines will be looking like. Okay, what's happening now? So we started, our early works is underway, so we cleared the land. We did this before the snowstorms. There's some before and after. And part of it was we salvaged all the trees. I heard the community people talking earlier about the whole idea about people cutting down trees and where can they get their trees from. So what we did was we went to the community and we lotteried off all of the wood. And 21 loads went into the community, mostly to seniors, indigenous, and veterans, right? And that's just an example of, you know, we're early on. What can we do to help the community while we're building this mine? Okay, so what's the next steps here? So the early works is in progress. We've got to get into a little bit of detailed engineering. We have some Canadian Tire money right now that we have to use. And so we're just being very specific on what engineering we go after. And in the meantime, and in parallel with this, the senior corporate team is over in Europe raising the money right now. We're anticipating that sometime before the end of this year, we get the major capital that supplements our capital plus the investment that Sandvik is doing with us and Continental Conveyors. So that's going on as we go. The permitting is very well advanced, and we're really into the procedural permits now. The big meat and potatoes are basically set up for the development plan, and the next phase will be the major phase, which is when we put the twin declines in, which would be in about 9 or 10 months. And stakeholder engagement and working with the community. So we have that steering team working, and we meet with them on a regular basis. We've got Sherry and the rest of the team here that work very closely with the community, so we know when something isn't kosher because they let us know. God bless them all. That's all I have. Any questions? Do I have time for questions, or do we move on here?
Yeah, you got time for questions.
Okay, Bon Jovi's coming on right after me, so we better move quickly through this here. Any questions? Yes?
What's the anticipated time to drill the entire shaft?
The twin declines? 18 months. Was originally when we were going conventional, we had it timed in 12 months, but like I said, once you get away from conventional mining, you're into a situation where it's a lot more of a construction project, a channel, if you want to call it something like that, to deal with.
This might be obvious in this audience, but I was curious what a road header is.
I don't have any pictures of it, but picture a head on a machine creating a road underground. I don't know. It's yes, right? It just goes up and down the face because it's soft enough to be able to go through versus drilling holes, filling it with explosives and blasting. Yes?
Not the pilot holes that you mentioned. What were the depths, basically, for exploration holes?
For what we're doing here, it was about 200 meters. So what we did was we followed the decline at different depths, right? So as we got closer to where we would break through into the salt, they got longer. And where we essentially break into the salt is around 250 meters. The twin declines are minus 15%, so in around there if my math's off a little bit. Yes?
Live registering on your website to gain access to your tender agreements and local vendors. How would you be able to gain exposure to your tenant and their release to the public?
Sherry, you have an answer for that one?
Or I'm here. How would you gain access to your local tenders and your issue for procurement?
Yeah, so we're working on, we do have a link on our website now. I know we were having issues with it, so, yeah, we are working on all that.
Okay.
So that we are building up the database and it's in line with our approved benefits agreement with the government. So my best advice is to check that for anyone.
Okay, perfect. Thank you, Jerry. Thank you.
In regards to that, there's plenty of time because really the biggest piece we need to get into is the detailed engineering. Hatch is going to be doing the detailed engineering for us with shafts and tunnels, doing the detailed design on the declines. So we're really excited about the team we're putting together, and that will all flow in terms of the suppliers adjacent to the contractors that we'll be bringing in to do the work as well. All right. So with no further ado, here's Bon Jovi.
The Bay of Peninsula, but the region as a whole. FireFly Metals they have a plan in place that will revitalize the former Ming mine. They have seen significant changes and increases in their resource as well as their process. So I'd like to welcome to the stage Mr. Gus Simbanegavi, the VP of Operations for FireFly Metals. There you go. This is forward. This is your thing. Yeah, and if you would like to use this, you can walk up to the stage.
All right. I guess I'll just go with the theme of using the mic. I guess it's more relaxing and I guess more engaging doing it that way. So, yeah, I'm going to sort of give a short overview of the FireFly Green Bay project. But I'm not going to go into the detail of geology, the ore body, and the overall company structure. I think a lot of those presentations have been done by our CEO. He does a really brilliant job in terms of sharing that. So today I'm going to put on my engineering hat and sort of like touch on key considerations which we are sort of like working on in terms of putting our study together. Just a brief background of FireFly for those who don't know who FireFly is. So as shown on those two little corner flags there, we are an Australian listed and Canadian listed company. So we operate on both the TSX and the ASX. So we consider ourselves Canadian Australians, that's the team. So the team itself has got quite a diverse team of people, and we are working pretty much across different time zones to make sure that we execute this project. A lot of things which we need to sort of like put in terms of forward-looking statements. Because we are a listed company, there's certain things which we can say and certain things which we can't say. So when you see me not saying a lot of numbers, my apologies is because there's certain things which we are sort of like regulated from saying and not saying. I'll start off by just giving a quick background of the history of this project. A lot of you guys know that it emanates from the old Rambler. And the old Rambler operated this mine for, I think it was operated in the 70s and shut down in the early 80s. And in 2009 to 2021, 22, it again ran. And the fundamental difference in terms of how this operation ran was that it was primarily focused on what I call a small scale. They were doing about 1,000 tons a day operation. They had running the mine at Ming Mine, which was on the corner of the 418 highway to Lassie and Ming's Bight, tracking the ore about 52 kilometers to Nugget Pond, where they were processing the ore. Once the ore has been processed, they were trucking the concentrate all the way around to Goodyear's in Southbrook, almost 162 kilometers away. So they ran sort of what we call a scattered operation with pretty much low economies of scale. So what has happened in the last 2 years, ever since FireFly came on board, is that we focused on understanding the ore body and growing the ore body. And we have defined quite a significant ore body size, which supports a significantly larger scale of operation, which is what I'm going to talk to you guys about in the next couple of slides. But as per our previous release, we now sit with over 70 million tons of material grading at 2% copper, which is a significantly high copper grade. It does not only come with copper, it also comes in with a lot of gold. at the current gold price, gold actually contributes almost 30 to 35% of our revenue and our project revenue going forward. So, what were some of the things which we were considering as we're sort of like putting this project together? I sort of like put it into 4 buckets. The first bucket, again, was just to try and address the historical issues which are linked to the scattered infrastructure layout. So we went back on the drawing board with a clean piece of paper and say, how are we going to set up this project from scratch? Let's make sure that we address the issues around the scattered nature of the project. The second bucket was, I guess, location and trying to look at some of the legacy issues within the existing infrastructure, where we wanted to put the infrastructure. We did a lot of work around the TMF location, the mill location, the boxcut locations, and the locations of infrastructure as a whole. Our main consideration was to try and integrate the existing infrastructure which we had at the Ming mine and the new infrastructure, so that we can optimize the capital footprint and the capital cost, but also make the project a sustainable, long-term, cost-efficient operation, and sort of like de-risk some of the historical issues which I highlighted earlier on. The other one was to look at the actual ore body itself based on the drilling which was done. It's quite a deep ore body, and we sort of like took a step back to say, how best should we approach it and how best should we be mining in terms of the supporting infrastructure. So one of the things which we'll sort of like touch on in terms of, the options we looked at in terms of getting the vertical shafts back online, looking at the decline, the size of the declines themselves, and using that as part of our sort of like considerations for putting it together. Quick ramp up and startup was pretty also important. So as we looked at all those access options, we wanted to make sure that we can ramp up pretty quickly. And lastly, the last bucket, which a lot of speakers spoke about earlier on, which was the fundamental bucket in terms of what we want to do, is the community, the environmental and community engagement. Just the whole thing, the theme which was being spoken about earlier on, about getting people involved, getting stakeholders involved from early on. And I think I'll speak about it a bit later on again as I proceed in terms of our processes and how the team really worked on early engagement of the various stakeholders. So the footprint itself, this is how we then sort of like consolidated everything around the Ming mine. Just as an orientation, I'm trying to find if I can get, here we go. So this is the highway to Lassie. This is the road to Ming's. And our current mining operations and everything now, the old ones, just sit right there. And what we have sort of like done now was to come in and say, where do we put the new infrastructure, and how do we incorporate the new infrastructure? So the first one was the portal. So we put in a portal on a location, which makes sure that it's got close proximity to the process plant. So we located the portal itself at a location which is close to the shaft. The processing plant itself, which then integrates with the portal decline, the ROM pad and the ROM pad facilities that's next to each other, and we've sort of like aligned it so that we do not double handle, we don't double handle material, and we limit and optimize the feeding rate through the process plant. One thing which I'll also speak about again a bit later on and also highlight is the paste plant, something which was not part of the previous work and the way they were doing the mining. And we've now incorporated paste and paste backfill as part of the mine design going forward. The tailings facility itself, I mean, we took a lot of iterations to get the tailings dam location in place, and that's where the tailings dam is going to go. We're also going to put in place a wastewater management plant so that we make sure that from an environmental and compliance and regulatory compliance perspective, we've got a water treatment plant. There's things like explosives magazines, where the storage of the magazines of explosives will go. The proposed new shaft, the location of that, and why we chose that particular location. And then the accommodation facilities, which is a key component of the whole project and the setup of the project. So I'll sort of like now go into the like high level of each of these components which I've just shared with you. So the first one is the portal and portal access. So what we did with the engineering team is we wanted to make sure that we've got early access, quick ramp up, and bring back the production of as quickly as we can. And the decline option provides that flexibility for us to do that. So we went in and we put in a small footprint where I said that the portal is going to go. But this portal is pretty much a small footprint. It's going to be covered with AMCO sets on top of it so that it's got very, very, very minimum impact in terms of the surface footprint. This will be connected with what we are calling a bypass ramp, which is a large tonnage ramp which we have designed to go and access the ore zones, which are slightly deeper down. What you're seeing there is the old historical mine with its own decline system, which is there. We went with the option of going with the bypass decline purely because of the magnitude and the volumes which we want to move. The existing decline is a small 4.5 by 4 meters, and whereas we are looking at a 6 by 6 large ton decline, which is going to allow us to put in much larger trucks. I think we're looking at a 63 to 65 ton truck. One of the things from I guess, as part of the things of the 4 boxes I spoke about is just making sure that from an ESG and sustainability was to make sure that we locate the ramp itself in the hanging wall. And there's a reason why we actually put the ramp in the hanging wall. Our rock characteristics in the hanging wall allow us to have what we call non-acid generating material. Normally, copper deposits and material you mine from a copper type sulfide deposit. It's got a lot of acid generating material, but also from a construction perspective, we wanted to make sure that we've got places where we can bring forward material to use for all our platforms, our pads, and our road constructions, and all the things we are going to need material for. So part of positioning it there was to make sure that we've got access to that material. That's sort of like a high-level overview of the mine itself, without going into too much detail. What you're going to see is the bypass ramp, which I showed you as it loops down and connects up to the ore zones, which all sit here. These top sections here are already mined out. That's the historical mine, and our footprint is all targeting this area here. We will use existing infrastructure where we can. We will use it, but we're also looking at putting in new ventilation shafts so that we can increase the volume of air down there. And eventually, we are looking at putting in quite a significant, almost a 3,500 feet shaft down to the bottom of the mine, which will be the future production shaft for bringing the ore out. So the decline allows us to have early access to ore, and the shaft gives us the sustainability, the long-term access to all these deeper sections of the mine, which will be mined for, I guess, many years to come. The process plant, was a lot of, I guess, historical known, because we had the process plant at Nugget Pond, but Gerard and the team sort of like optimized through additional test work to see what we can actually push the process plant to. And one of the key additions which we have done to the process plant is to make sure that we actually maximize gold recovery. I spoke about the 30 to 35% contribution of gold at the current gold market price. So our flow sheet and our design for the process plant is a typical process plant where we have got feeding from the ROM pad into a primary crusher, SAG, ball mill, flotation, and thickening and getting us concentrate. But one addition is that we are going to scavenge off what we call our pyrite tailings for the metallurgists and processing guys in here, which will then leach for gold. And we'll have 2 gold streams, some gold in the concentrate, but we're actually going to make gold door on site as well as part of this modification which we have done. So this is quite an efficient process plant. There's sort of like a 3D visual which I've sort of like put in there where the crushing is, the stockpiles. You'll see there part of our optimization process was to make sure that we've got a compact design of the process plant, which is neat, then the material flows pretty easily. Maybe to highlight there that some of the test work and the design criteria which we are using, the recoveries, we're looking at 98% recovery for our copper, up to plus 83% gold recoveries through this designed process. I spoke about the paste, the importance of the paste backfill, because it's a significant addition to sort of like our design and layout of the mine. What the paste plant does and why it's so critical in it is that it's going to allow us to backfill almost 50 to 55% of the tailings material which we are going to generate or mine over the life of mine. The impact of that is that by backfilling that underground, it allows us to reduce our tailings footprint and the considerations for the paste footprint. But also, it allows us to have significantly higher extraction ratios. It means that we are going to mine way more from the resource, less pillars we're going to leave underground because we're going to be using this paste backfill. Something which I guess was not part of the previous plans, but something which will really add a lot of value going forward for this project. So this is the tailings dam design itself, the one with the reduced footprint, and some of the sort of like smart ideas and the things which we considered as we were putting up the project is things like we have incorporated what we call an aggregate quarry. Remember, the underground miners are going to be giving us non-peg material, which we're going to use for construction, but we are also going to have an aggregate quarry within the tailings dam itself. Okay, sorry. All right, I'm just gonna get everything out there. So I was saying, aggregate quarry within the tailings dam, it's itself. I've already spoken about the location of the tailings, about that we looked at various locations before we finalized on this particular one. So one of the things which we also considered is the is that we've got a lot of legacy areas, existing potentially acid generating waste rock on site. And part of the design and the design consideration was to incorporate using some of that material, cleaning up the environment, using it as an inner liner which is going to be submerged within the tailings dam, thereby allowing us to rehabilitate as part of the some of the legacy issues within the project footprint. Maybe just a point there as well is that this is going to be a closed water system with a wastewater treatment plant sitting there. We are going to recycle most of our water, which limits the amount of water which we are going to be getting from all the sources. So the only water which we are going to be using is pretty much makeup water. The most of the water which we are going to be using is going to be closed a loop within the system itself with very little water used. So I'll move a little bit further on. I'm just looking at the time here. Is on just the whole issue around the sustainability involving of community and the early engagement. I've thought I'd put it into 6 quadrants, and Tabata has done a significant amount of work in terms of making sure that the whole process from community engagement, working with community and community feedback. I mean, one of the things we are proud of is that, I keep pressing the wrong one. One of the things we are proud of is that we have done surveys from the onset. We've included most of our community members from the onset, even including their involvement in choosing places for the tailings dam, looking at the infrastructure, and the responses which we are getting from the community members and the support we have for the project was overwhelming. I spoke about the land use, the legacy issues around land. Some of the issues which we currently have historically at the Rambla side, those were all part of the consideration in terms of making sure that where we can, we rehabilitate, where we can put infrastructure around some of those things we did, and just basically minimize disturbances. I think partnership with municipalities was something which we did from the onset. And the collaboration with all the local municipalities, the Bay Peninsula, I guess it's blessed. It's got quite a lot of communities around us. I think we've got 14 or so small towns around the project area, and all those small towns has been part of the people who have engaged and taken along from the onset of the project. We continue to work with community in terms of development and identifying economic development project, and that's going to be a key aspect of our project. And of course, the ultimate objective is to make sure that we create employment, but not only that, is to create economic resilience over time. It's not just about running the mine for its life, but it's making sure that it's set up for being resilient over time. Just getting on onto that in terms of some of the things which we do as part of our engagement and involvement. We don't stop there. We are now starting to look at getting ourselves involved with most of the organization within the province as we look at setting ourselves up for the project. I think Bonnie and the team are very much working hand in hand with the women in resource development, making sure that we promote engagement into promote women to get involved in mining. We work with the CME, which is the manufacturing. I think there's a lot of programs which they did on site previously. And also, we work closely with the local chamber, the Bevet local chamber. We are involved in terms of shaping what is happening within the community. We have started focusing on training. We believe that training is going to be an integral part of this project. We see ourselves, I guess, going up to about 400 to 500 people on site. It's a steady state for the life of mine. But during the construction phase, that number goes to about 700 to 800 people, even more than that. So we need to make sure that we start encouraging from school kids to women, to training of the required skills so that we are set up for the project. Maybe just as a statement, basically to say sustainability occurs when projects are designed with communities. I think that it was a revolving message earlier on. And by the way, when we put this slide deck together, we didn't even know that there was going to be a discussion like that. And it was quite encouraging to hear the conversations earlier on some of the things we are sort of like prioritizing as part of our project development plan. So where to next? This is where we are. So we are not yet at where we can talk about some of the significant numbers which the previous presenter shared, but we are almost there. So watch this space in terms of the release coming in I guess during this first half of the year. So we are hoping that we are going to release our PEA document by end of June. That should be done. Most of the aspects of the project have been done. So we have ticked, most of these green ticks have been done or are being finalized. So we are at the tail end of making sure that we consolidate the entire project and release it to the market soon. We've worked with a lot of partners, and some of you guys are in this room. We've been part of this journey for the past 2 years of putting this project together. And we want to thank you for that contribution. I know it's been a lot of long hours in working across different time zones in putting all of this project together. So this is what I believe the future will look like, where we are going to bring back underground mining, and this project is going to be a significant flagship in terms of bringing back underground mining onto the island and onto the province. I know that there's mining happening at Voices and others, but this is different in that the future we are going to go back to the old days of Buckens where there were shafts and go back to being leaders in shaft mining into the future. And that's what I had for you, and hopefully in the coming presentations or next time we will have all our project economics numbers available to share with you guys.